global private backbone, right? Before we start, I'd like to share with you one of the real story, right? I believe some of you may have already heard of this, right? The Google Cloud last week actually got a major outage. I mean, all the major business locations, as you can see, right? The problem is not only about the Keto, sorry, it's not only about, Google. Some other SaaS providers which are relying on Google to provide a service also got impacted. I mean, as you can see, the service outage lasts around 10 hours, which greatly impact the customer's service. Right, but that's not the case for Keto. The reason behind is for Keto, we are not designed this way. We have followed a few design principles, allow Keto not to rely on any public cloud providers. The design principles I'd like to share with the team is also known as Keto SaaS DNA. The first one is converge, which means instead of using multi-point product service chaining together to provide the service, we are using a converged architecture, which combines both the network and security into a single software stack. And second one is a cloud native. We built this platform from ground up using a cloud native architecture, which gives the customer more scalability, agility, and resiliency. And also we're using a single management application, which means the customer only use one single portal to do the visibility, control, operation, and troubleshooting. You no need switch between different portals. And we support all ages, which means all your branches, data centers, mobile users, public cloud or SaaS application will connect to the same SaaS cloud provider and get all the network and security service. And the last and the most important part is we have a global coverage, which I will show you today. We have a global private backbone to deliver the service. Just keep in mind, Keto is the only SaaS vendor with a global private backbone. There's so many SaaS vendors in the market, but Keto is the only one with this global private backbone. And ever since day one, Keto was founded from 2015, we have been building this Keto private backbone with more and more POPs. Until now, we have 85 POPs across all the major business locations. As you can see from this diagram, we cover EMEA, Europe, North America, Asia, Latin America, and Middle East and Africa. So all the customers, no matter where they are, they always connect to the nearest POP in this region, give them ultra low latency and high performance. Just a bit more information about this Keto SaaS platform, right? This architecture, right? It helps us to understand a bit more about our solution. So Keto, in order to deliver this service, we built a global private backbone connecting all the POPs. So each of the POP basically minimum have 2 tier 1 service providers. So even one service provider is down, or maybe, for example, downgraded, you still have another one to provide the service. And each of the POP actually is running what we call a space engine, a single pass cloud engine. This is the secret of Keto's service. Basically, this space engine will converge both the network and the security. From the networking side, what do we do? Basically, for all the traffic from all the edges, for all the protocols, all the port will be precise and also will be accelerated and optimized. We can do TCP optimization and UDP packet loss mitigation as well. And also customer can do the selective decryption. They can turn on TLS inspection as needed to see what is inside the layer 7, and then they can use this layer 7 information to cite your policies, to do your security inspection, to cite your control. And on top of that, we provide the DEM capabilities, digital experience monitoring, to give the customer the deep insight about the application performance, the user experience. On the security side, we have all the security capabilities, as you can see from here, for the threat prevention and data protection. The traditional firewall capabilities, for example, layer 7 NG firewall, secure web gateway, IPS, DNS protection, next generation anti-malware, sandboxing, ZTNA, CASB, DLP, RBI, IoT, OT, security, all these capabilities are running as a service in Keto. I just want to highlight that all these security service the customer can turn on as needed. Is very flexible. And one thing I want you to take note is no matter what feature you turn on, there's no performance drop. If you are using a hardware-based solution, one of the main concerns is when you turn on certain features, the more features you turn on, the performance will be dropped a lot. But with Keto, as we are using a cloud-native architecture, when you turn on any of the capabilities, there's no performance drop. And in order to use these capabilities, basically we offer you a few options to connect to Keto SASE Cloud. The first one is using our SD-WAN solution, which we call a socket. This one can connect to the nearest POP automatically, and also it support the path selection, QoS based on application and identity, and also you can have NG firewall inside the box itself to do LAN segmentation. And for data centers, we offer another connectivities using IPsec. The customer can set up IPsec connectivities to the POP they selected. They can have active, standby, active tunnels as needed. And for the mobile users, basically they can connect using a client. This client can be installed on any platform like your handphones, like tablet, and your macOS, your Android device, any device. Basically, they will function the same as the socket. They will connect to the nearest POP and use all the network and security service. And for the public cloud, basically, we also can seamlessly connect to the public cloud. They can connect using a virtual socket or using an IPsec. We also support interconnect from our POP directly to the service provider using this cloud interconnect, which provide ultra low latency, very high performance. And for SaaS applications, we can use smart egress to select the POP close to the SaaS server to do the SaaS optimization. As you can see from here, all these components, all the traffic flows through this Keto SASE Cloud. All the data we collected will be stored in the single data lake. So from there, we can apply AI and machine learning to show the customer, to provide the customer XDR stories to show the customer what's the potential threats in the network. And also they can use this for the SOC and OC team. All these capabilities is in one single portal. So from there, you have a role-based access control. You have rich network and security analytics. This can be co-managed, can be self-managed by customer. Right. As you can see from here, this architecture is a bit unique in the market. No other vendors is using this because Keto, we built everything from ground up, from scratch. And at the core of this architecture, as you can see, is the POP, right? So the number one question is, what is inside the POP, right? I believe a lot of other SASE vendors also provide POPs. They may also provide you a status page. You can see all the POP status. But not all the POP are the same. This is a quote from Gartner, right? I mean, SASE solution is cloud delivered, but the cloud nativeness of the architecture may be different. Like the appliance, virtual appliance architecture need to be break down to smaller, scalable components. That's why when Keto, we design our architecture, basically, instead of using box or VM put in the public cloud, we are using a microservice. Basically, this microservice can give you better scalability, resiliency, and agility. So let's take a closer look at inside the POP, right? So inside the Keto POP, they have multi-node, and each of the node, they have multiple space engine, just previously I shared. So as you can see from here, all this space engine, all this node can be used by any customer. It can be dynamic load balancing. So over the customer, they will connect to the nearest POP and it can be connecting to any of the node based on the, resource the node have, right? This is a cloud scale. This is the self-healing because we are using a microservice. And comparing to some other vendors, they may put a VM in the cloud, which we call a cloud appliance, which is static binding only to specific customer. And also there's no load balancing. And also, no matter how much CPU and memory you allocate to the VM, it's still a box scale solution. When it comes to the HA setup, it's very complex. It needs to be set up per box per region. So you can see this is totally different solution. As for Keto, we are built for cloud delivery. As you for other vendors using a cloud appliance, basically it's built for customer premises. So we know what is inside POP. How about the connectivity between the POP? So if you have multi-POP in the region, basically all the POPs, they are totally location independent from each other. And the service is elastic, which means we will dynamic adjust the resource as the request changes, right? It's also dynamic load balancing, it's self-healing, and also it's self-maintaining, which means this is, I mean, whatever, for example, the customer, how much traffic you need, you never need to worry about that there's not enough resource, right? All this will be taken care by Keto. The customer just need to focus on their business. Just a bit more information on Keto Space Engine, right? This is the secret of all the network and security service, right? For all the capabilities, all the traffic, we share the same context and the policy. How it works, basically, when the traffic flows through Keto SASE Cloud, from any edges, from the branches, from the users, from the public cloud, from I mean the LTOT device, all this traffic. First of all, what we will do, we will extract all the context. For example, the identity information, layer 3 and layer 4 information, up to layer 7 information. And also we collect, for example, what the device you are connecting to, what kind of OS tab you are using, what is the last mile ISP you are using. If you are using a browser to access the application, what browser you are using. All this information, hundreds of contexts will be collected. And we can use this context to share with all the different engines it will have, and we can apply a single policies, including network policies, access policies, security policies to the same traffic. So from there, it's not only improve the efficiency, but also all the traffic, I mean, when the traffic passes through once, all the policy will apply. That's why for Keto, we can give you very high performance. In the single edge, we support up to 10 Gbps with the full security inspection turned on, with the full decryption turned on, right? So this is one of the key differentiators. When you turn on, for example, the security device, security engines, we will turn on the DRS inspections. Basically, if you're using a hardware-based solution, there's a lot, maybe 90% performance drop. If you want to achieve 10 Gbps report, maybe you need a very big box, right? That's not the case for Keto. So we know what is inside the POP. So the next question is how these POP are connected, right? So before we talk about the Keto, let's take a look how other vendors, how they connect the edges, right? For example, suppose you have a branch, you have a data center, right? Basically, most of the vendor, what they do, they set up certain tunnels between the branch and data center. This can be a DTLS tunnel, can be IPsec tunnel, can be some proprietary tunnel, right? So if you have more branches, basically you need more tunnels, right? This tunnel, they then depends on the traffic flow, can be dynamic tunnel, can be static tunnel. And also most of customer, if have, for example, cloud data centers, you still need to set up the tunnels between your branch to the cloud data centers, right? And also between the on-premise data center to the cloud data center, you may also need to set up some tunnels because you need some database backup synchronization in between, right? So as you can see from here, there are a few problems for this kind of setup, right? First one, you need to choose between a HubSpot or full mesh topologies. For small branches, there's not enough resource to support full mesh. That's why sometimes you need to choose dynamic tunnels, right? And also it can be very complex setup because why? Because for example, one regional headquarter is the hub of this region, but this regional HQ can be a spoke from a DC perspective, right? So if you have multi-layer, yeah, you need to think about which one is the hub, which one is the spoke. It can be very complex setup. And also, all these tunnels mostly is built on the internet, which means it's best effort service. There's no performance guarantees for this connection, right? So this is one of the typical setup for other vendors. And there's another, I mean, some other vendors, they may improve, I mean, slightly improve than this architecture. So what they do is for the branch traffic, instead of sending directly to the data center, they may send to certain POP. For example, this is a VM in the public cloud or in the region. And from there, they do the TLA inspection, they do all the security inspection and send to the public cloud or SaaS providers. So as you can see for this setup, actually, it's slightly better than the previous one because they still have the last mile optimization in between. But also they have another problem. The first one is they only have a limited POP per region. So even they have maybe hundreds of POP around the world, but you only can use a few POPs in particular region. All right, if your destination in other region, sorry, you cannot use the other region in the POP. And another problem is between the different POPs, actually, they don't talk to each other, which means there's no minimal optimization, right? So as you can see from here, no matter which one you use, either it's a complex setup or it's very difficult to guarantee the performance. So what is the solution for Keto? So as for Keto, as you can see just now, right, this is the architecture. We totally change the topology, right? We do it different way. So as you can see from here, all the edges, no matter it's branches, data centers, or it's the mobile user, public cloud, or SaaS applications, all is connected to the nearest port. So each of the box only need to maintain a few connectivity, right? And no need to talk to other side directly. And we use this global private backbone to deliver the packet based on the destination, whether it's branch data center or branch to cloud data centers or branch, for example, to SaaS applications. All go through this global private backbone. As you can see from here, it's a very simple setup here, right? There's no hub sport and full mesh topology you need to worry about, right? Everything need to talk to the POP only. And also you have very granular control based on the traffic direction. Whether you allow this branch to talk to the data center or cloud data center is all based on the policy you can fix, right? You can have very, very granular control. So this will perfectly address the previous, the connectivity issues. I think another question most of the customer will raise is, okay, since you are connecting to the POP, what if yes, there's something wrong with your POP, right? So basically, when we design this architecture, we put redundancy and resiliency in every layer. Just for your information, for example, if the if the branch or the user is connecting, for example, to the POP, nearest the POP, they will allocate one of the best nodes to take the service. If the node is not reachable, another node in the same region, in the same location, they will cover it and take the workload, as you can see from here, right? For example, the node you connected is offline due to some crash or whatever reason, right? The other node will automatically take over. And in case the whole location, the whole POP is not reachable, maybe for example, it's because of maybe the power outage, the whole data center is down, right? Or maybe whatever other regions, right? So in case the POP is not available, what happens is another POP in the same region will take the load. All this will happen automatically. The customer no need to do anything, right? And what if, for example, as we know, as I said just now, right, each of the POP is using two tier one service providers. What if, for example, one service provider is downgraded or maybe, for example, is offline? Maybe the C cable got cut off, whatever reason, right? So basically what will happen, right? We have two tier one service provider. When one service provider is downgraded or maybe, for example, is offline, we still have another ISP to carry the load. And also, we automatically tell the rest of the peers to drop this POP for the future ingress and egress traffic. So the customer, they can still, for example, enjoy the full redundancy of all the POPs. All right. So no matter it's an infra issue or it's a carrier issues, we all have the redundancy in place. That's why for Keto, we give the current customer the 99.999 SLA in our master service agreement. This is this is a compromise. This is something we can promise to the customer, right? So we know what is inside the POP. We know how the POP are connected. And next question is, how about the performance, right? Even you're using the tier one service provider, is still, for example, it's still a internet, right? It's not MPLS. How about the performance? So just want to give you some background information. For the ISPs, basically come into three tiers. Tier 1 ISP, basically they have global coverage. They can pair with other tier 1 ISPs with no extra cost. This kind of ISP, like for example, AT&T, DTT, Telia, this is the tier 1 ISP. There's also tier 2 and tier 3 ISP. Well, tier 2 ISP is basically regional ISPs, right? For example, like Syntel, like Testra, like PCCW. they need to peer with other tier 2 ISP to keep the cost lower. And also they have tier 3 ISPs, basically the local or national ISPs, like for example, in Singapore, we have MY, Simba, this kind of ISP only operates in the territory only. All right. So even you subscribe, for example, your local ISP, you subscribe a very high bandwidth, very good connectivity. Sometimes you still have performance issues. Why? The reason behind it is because within the ISP network, as you can see in the last mile, you have the routing and the performance under control. But when the traffic go beyond the local ISPs, there's nothing you can control. This is why the bottleneck, the congestion, the data and packet loss will be introduced, right? So even you have a very good last mile as a line, you may have the performance issues. And also some custom maybe, for example, subscribe MPS link, but the problem is you need to have a compromise between the cost and the performance. So what is the solution? The solution is using a global private backbone with tier 1 service providers. So as you can see from here, from the source to destination, basically, you have the routing and the control and give you the guaranteed performance beyond the local ISP, right? You have between the source port and destination port, right? No matter where they are, right? You have the routing and the control. That's why we can give you, for example, this is one of the test results. As you can see from here, using Keto, we have the jitter greatly reduced from 260 milliseconds to 20 milliseconds. And you can also see the APF, the performance is much more stable. Right. So tier 1 service provider can guarantee your performance and also have the routing and the control. But we are not stopped there. We are moving a step further. We can give you the network and SaaS optimization with our global private backbone. So how we do it? Basically, we are doing a multi-segment optimization. So as you can see from here, from the source to destination, right, there are multi-segment. For the last mile, right, is between the branch to the nearest port. Basically, from here, you have multi-transport. You can have active path selection. You can have better QoS based on identity and also based on the user, based on application. And also you can do packet loss mitigation for the UDP and the voice traffic. Basically, for example, if your voice have high packet loss, basically what we can do, we can duplicate packet and send over the both link, right? So even you got one copy loss, you still have another copy and no need retransmission. For the main mail, this is where our global private bond take place. You can see from here what we are doing. We can do TCP proxy. We can do optimal global routing based on multi-carrier. And also on top of that, we can do cloud optimization for public cloud for SaaS applications. So instead of doing only last mile optimization like some other vendors, we actually can do end-to-end optimization, right? So just want to give you a bit more information on TCP acceleration, right? We know, right, especially for long haul distance transformation, if the high packet loss, right, with TCP got this issue of, for example, slow start, they also need some retransmissions. But with Keto, right, as you can see, they are not directly connected to each other. They connect to the nearest port. So basically what we can do is we are using the TCP proxy to trick the client and server, thinking that their destination is closer, right? So in this case, we can allow a larger TCP window. And also we can apply advanced congestion control, right? So in this case, right, I just want to show you some real world examples for file transfer, for example, from the branch. We'll download some files from AWS, 3 GBP file. As you can see from here, in the left is with Keto, and on the right side is the public internet, right? It's same last mile, but as you can see, right, on the left side with Keto, we complete a 3.2 GB file in around less than 4 minutes. On the right side, actually, as you can see from here, right, it's much slower. Actually, the total time I want to show you is take around 45 minutes. Of course, different customer, different environment may be slightly different, but we can see that using Keto, we immediately got around 15 times improvement. Right, so this is basically inside the network for the east-west traffic. And also we can do SaaS optimization for public SaaS applications. For example, a lot of customer using Salesforce for the ERP system. So if you are using internet to access this application, it's best effort. There's no guarantee for the performance. For the users working from home, working from mobile, from Starbucks, basically they have, I mean, sometimes have a very poor appearance. As for Keto, what we can do actually, for example, you can see from here, we can select the path close to the SaaS server. As you can see from here, I'm in Singapore. I connect to the Singapore path. I can select the egress the traffic from, for example, a server in Frankfurt close to the SaaS server. So from this case, it's like a build a highway from the doorstep to the SaaS application server. In this case, we can improve the performance significantly. Right here is another examples we have done in Philippines. Right, this is from one of the customer production network. As you can see, we are downloading a file using our Keto client. Basically, I want to highlight, right, our optimization not only apply to the user in office, but also apply to the user working from home, work from anywhere, right? As you can see from here, when downloading the file from Salesforce, actually, I download a 300 MB text file. Basically, with Keto, without Keto, using the same internet, same laptop, same last mile connections, same destination file, you immediately achieve around 40 times improvement from 130 KB to 5.5 MB. That's something we can do for the mobile users, greatly improve the user experience, right? So we talk about TCP optimization. Then, but on top of that, we can do global route optimization, right? So as I said just now, right, all the POP they are connected to each other. Basically, what we do, we build a full mesh to peer connectivities using an encrypted tunnel, right? So every POP they will talk to each other to understand what is the best path from the source to destinations, right? And also we support multi-POP communication. For example, if I'm in Singapore, I want to talk to the server in US, whether it directly go to the US, whether it stop over in KL, whether it stop over in Japan, then send to the US. It all depends on current the status of the network. And also, we can constantly check the peer levelness. We measure the RTT and packet loss on all the connectivities. So we will select the best path from the source to destination. And beyond that, we also do X peering, right? So we know X peering basically a wide spectrum range of X members typically give you a better routing, better RTT, and better price. So basically, as you can see from here, I just masked some of the detailed information. So basically, we can peer with some of the major service providers like Tesla, like AWS, and also some of the major applications like Microsoft, like Facebook, like Cloudflare. So we give you a better route, right, from the source to destination. When you go visit these applications, actually, you can greatly reduce, for example, latency and choose the best source to destination path. Here, I give you one example, right? I'm in Singapore. I want to access some server in US, in Texas. So as you can see, we are doing a trace route. Basically, as you know, this is internet, right? This is the best effort service, right? There were multi hops, and where is the pop, where they go, I cannot control, right? As you can see from here, from the source to destination, I have around 14 different hops, right? And the total latency is around 309 milliseconds. That's something you cannot control. It's best effort service. But with Keto, as you can see from here, basically when we do the same trace route to the same destination, what will happen? Two hops and arrive. And you compare the latency to the previous one from 309 reduced to 206, right? 100 millisecond, around 50% reduction in the latency. That's something we can do for the customer because our global provide very well, because of the technology we are using, right, to improve the performance, to reduce the latency. Of course, sometimes depends on the path, it depends on the Keto backbone, the status. The latency may be, for example, not so significantly reduced, right? But we can tell most of the customer, right, even without, for example, some of the performance, maybe the latency not reduced a lot, but still the customer have a reliable and consistent performance guarantee because Keto give you 99.99 availability SLA, right? So we know right now what is inside the POP, how the POP are connected, what kind of technology we're using to improve the performance. And another common question from customer is, how about China? How about channel connectivity? Why this coming into the picture is because mostly with the customer, they have operation, they have branch office in China, they're facing an issue, this great firewall issues, right? The regulation issues, right? There's some requirement for connectivity to China, right? First one, most important one, of course, we need to make sure your solution meet the local regulations, right? And also, we want to guarantee the performance for the China user when they access application outside of China, right? I give you one example, like Microsoft. Basically, the Microsoft in China and Microsoft outside of China is totally different instance. That's why sometimes when the user they want to access the instance outside of China, they may facing some performance issues. And also, we want the same level of protections for user in China and outside of China because they belong to the same operation, same company. At no point to set two different policies, right? And also, we want to simplify the management. I don't want to buy the ISP line from China myself, right? I don't want to subscribe another contract. Maybe, for example, I need to use another portal to manage all the service in China, right? So the solution from Cato is very simple. As for Cato, we have three POPs in China at this moment. We have Beijing, Shanghai, and Shenzhen. These three POPs actually all egress, all have the connectivity to the POP in Hong Kong, which means we are fully compliant to the China regulations, right? And also we provide the same level of performance, 99.99 SLA even for China. And they have the same full security stack, so they have the same security protections, and also they are using the same management portal for the management of China side of China user policies. So as you can see from here, previously you may need to have a headache of using how to connect to China, how to subscribe the local line, right? Right now with Cato, you totally don't have such issues. And also today we just want to focus on the global private backbone. I just want to give you some of the test results we have done for our China customer. This is for SharePoint in China, right? As you can see from here, right? Basically, we are using a Cato client to download the same file from SharePoint. As in the left side is without Cato, and on the right side, we're using the same laptop, same last mile, downloading the same file. As you can see, instantly you can see the performance. The download speed from 2.5 immediately go up to around 10 Mbps. Instant 5 times improvement. Right. So a lot of customers is moving to SASE. We know SASE, I believe a lot of vendors also know SASE is a trend, right? But the problem is for SASE, the key strength of SASE is not about the features. It's not about functions. If you look at the functions and features all of SASE provider provide, it's around the same, right? Both of them have some security features, for example, both have NG firewalls, have secure gateways, IPS, right? Class B DLP, right? These functions are similar, but the real problem is how to deliver a secure and optimal access for all the users. And also we want to simplify the management, right? So this is one of the code from one of our customer, right? I don't want my team to worry about how to get the packet from point A to point B. I only want to know our application behave the way they should? Are people getting the performance they should? And most importantly, are we secure, right? I believe a lot of other customers, I mean, they share the same view, right? As for Cato, right, actually, we built this global private backbone. We built our SASE platform to deliver the performance and security easily to anyone from anywhere, right? You can add Keto to do the heavy lifting for you, so you can focus on your business, right? So the takeaway for today is we have been discussing about our Keto path, the space engine, the cloud native engine, combine the both network and security in a one single software stack. We also discussed about Keto private backbone, which provide the control routing and guarantee the performance within 99.99 SLAs. And this backbone plus optimization, the TCP optimization, I mean the route optimization, we can provide the real world benefit 3 to 50 times performance improvement. And also for China side, China connectivities, we are fully compliant to China regulations. And also we can improve the chain size and performance and simplify the management using the single management portal. And last and most important takeaway for today is just keep in mind, Keto is the only SASE vendors in the market has a global private backbone, right? So that's the full session for today. And yeah, I think we can open for questions. Anybody got any questions? Feel free to ask.
Colin, there's a question in the
Mhm.
Q&A.
Yeah.
Muhammad asked, in Cato, we cannot use MPLS link for connectivity to private backbone.
Mm.
Question mark. As per my understanding, only internet link is supported. Please
Okay.
clarify.
Okay. Very good question. Let me go back to the architecture diagram. All right. So basically for Keto, as you can see from here, all right, if you want to connect to Keto's cloud, basically you must using internet, right? Because this Keto POP is sitting in the internet. But if the customer they have MPLS link, as you can see in this the diagram, basically what we can do, we can still keep the MPLS, but the MPLS is for the last result between the branch and data center communication. So this is in case, for example, your primary connection to the POP is offline. For certain reasons, for example, last mile is offline, you still have MPLS to deliver the traffic from the branch to the data center, right? So MPLS, you still yes, you still can keep it, but it's not used for connecting the POP. It's just for branch to data center communication, right? But it makes migration difficult. Not really. The reason we put this MPLS here is because for certain customers, for example, they still have the MPLS contract, right? It's not ending, so they still can keep it. But they, for example, they want to reduce the cost and introduce another internet line. And in this case, for example, you can use your internet line as the primary. You still can use your MPLS as a backup. And if, for example, you operate for a while, you move the SASE architecture for a while, and later you find out, okay, actually using the internet is pretty good enough for my, for example, for the connectivity, very stable, performance improvement a lot. Then slowly you can just discontinue your MPLS link, right? That's
One more thing I need to
yeah,
ask, like,
yeah.
regarding is Cato is a true SDN solution, because my point is, in
Mm-hmm.
Cato, everything is moving through a private backbone. But
Mm,
in SDN cases, like, the traffic, once the controller is established, the sessions, and then the data will move from edge to edge. But
mm.
it looks like in Cato, the traffic always move through a private backbone.
Okay, that's the default behavior. That's the default behavior. Everything is moving to the backbone by default. But still, you have the capability to customize the traffic for certain traffic. For example, I don't want to send to the backbone. Yes, you can do that, right? You can do that. For example, like a Teams traffic, the Zoom traffic. I don't want to send the backbone because it's quite safe already. I would don't. I mean, if my Zoom is very stable, it's very good already, I no need to send to the backbone, right? It all depends on your policy. We have a default policy to send directly to the POP, but you have the capability to customize what kind of traffic you want to send to Keto, right?
But I think MS Office 365, this is the cloud-based application traffic you are talking about. My question is, there are some set of applications set
Mm,
up in data center 1 and in data center
mm,
2. Now,
mm,
when the application trying to exchange the data, it
mm.
always going through basically Cato backbone, or they will establish a basically
Mm.
H2H tunnel and they will move directly.
All
Because over
this,
here, over here, the tunnels is established between basically from the branch or basically head office or from the data center towards the private
all right,
backbone, not directly H2H.
all right, correct, agree. So even you have a cloud data center, for example, they still need, if the cloud data center, like for example, from here, like AWS, need to talk to the one in this on-premise data center, they still need to go through this Keto private backbone. That's the design because the reason behind this is we want to make sure all the internal communication is protected and optimized, right?
Okay, great. Regarding the migration, because as you said, like we can keep MPLS link along with the basically internet link which is going towards Cato. But in
Yeah.
an organization where we are having multiple you can say MPLS link and going towards a basically Cato network, then like sometimes because when you are changing WAN link, it will give an difficulty in the migration.
Mm.
So what's your point on this? Like, because it seems like if I compare it with other solutions, because they ask about to keep all the links as it is, no much changes.
Understood.
That's keep migration easy. But it looks like Cato is good. We got good features, but initially when we are migrating the existing network, like migration is a challenge.
Yeah, actually, we have a lot of customer who migrate from the existing MPS to, for example, to Cato, right? Don't have issue. First thing is you can keep it MPS, no problem. Second thing is, for example, we have done a lot of tests, comparing the existing MPS to Cato, I mean the global private backbone, we can find out that for Cato private backbone sometimes can provide even high bandwidth, even high better improvement for the performance. The reason behind is for MPS mostly, for example, is very costly and the bandwidth is very small. But when you subscribe internet, the bandwidth can be very big. And with Keto Private Backbone, actually you can make full use of the bandwidth and the data transfer can be much, much faster, right? So that's why a lot of customers, when they migrate to Keto, actually, they can keep a small, very minimum MPS, for example, to a minimum amount of bandwidth. And they can use, for example, multiple last mile SPs for example, for the redundancy. You just keep the MPS for the last result in case all the internet is down, right? That's the best practice we recommend it. But of course, if you have, for example, still want to keep the old way, for example, if you want to have multiple MPS and maybe, for example, this is a major, for example, using for majority of the traffic goes through the MPS, right? That's something we can also support, but we need to discuss in detail. For example, you may need to some other device to do the redirect the traffic in front of Keto instead of using Keto to redirect. But we can help you to do the, I mean, to discuss more detail about the migration. If you are keen, we can discuss this offline, right?
Thanks, Mohammed.
Yeah.
If anyone
Thanks.
else would
Thanks.
like to take questions live, use the Zoom hand raise and I will unmute your line like what I did for Mohammed.
Yeah.
We have 24 partners, well, 22 because we have Cato employees. Does anyone else have any questions? You can type it in or raise your hand and I will unmute your line. I think, Colin, you did an awesome job.
Thank you.
So no
Thank you.
questions.
Yeah. No worry. If today you cannot think of any questions, you still can contact us, connect our team as needed, right? So we have
Karunya.
yeah.
Oh, sorry, Colin. Karunya, any closing from you, Karunya? Okay, folks. If there are no
Yes.
questions, yeah, go ahead.
So thank you everyone for joining. Sorry. And I think it was an excellent session, though there were very few questions. I deeply encourage you guys to email us or get in touch with your local channel managers and pre-sales engineers to get your questions sorted as soon as possible. And please help us answer this webinar post webinar wrap up query. It will help us get the next topic right, what you want to hear from Cato and which will be very useful to you. So just help us answering this query, this poll as well. Yeah. Just a 1 minute timing for this. Can you guys quickly start answering? Yes, I see a lot of answers.
So common question asked is the webinar is being recorded and we'll upload the recording in a day or two and we'll send out the link. It will be via Cato Academy. There's a lot of information in there, so I'll send out the very specific link via an email. So look out for it, share it with your team members, and rewatch the recording and Colin's presentation along with all the previous webinar presentations that we've had as well.
Yes.
Okay.
With that,
So
thank you,
looking
everyone.
forward to
Yep.
see you again next month as well. This is a monthly series, guys. So thank you for joining today. Yeah, have a great
Thank you,
week ahead.
everyone. Have a
Yeah,
good day.
bye bye.
Thank you. Bye bye.
Thanks, Prissy.